Hello and welcome. My name is Rams Polic. I'm a senior technical leader at Cisco, and I will be presenting Agency Directory, an open source registry for agentic resource discovery and management. If you're building with AI agents, one of the first problems you run into is, how do I find agents? How do I know if they're safe to use? And once I have thousands of them, how do I make them discoverable to others? That's the problem Agency Directory was built to solve. The idea is simple. Agent authors publish records describing what their agents can do, consumers discover them by capabilities, and the whole process is governed by policies and trust. In this video, we'll walk through the following scenario. You're an AI engineer with a task to automate. You need to find the right agents, verify they're safe, and put them to work without any manual coordination. For that, we'll use Agency Directory, covering the setup, authoring agents, discovering them locally or across the network, and using them in our workflows. We will use Claude Code as our agentic environment to demonstrate the full lifecycle. We start by setting up our own registry for agents that we will use throughout the rest of the demo. You run it yourself, you control what goes in, and connect to directories run by other organizations, forming a network where everyone can collaborate and discover agents. We begin by installing the agent skill, which packages everything we need to know when working with the directory. How to manage it, how to publish and find agents, and how to keep things safe. With the skill in place, we ask for the local environment to be set up. Behind the scenes, everything needed gets downloaded, the directory comes up, and a health check confirms it's ready. All we see is a simple confirmation that we're good to go. What we've just started is the place your teams publish to, the gateway through which agents get discovered, and the point where policies get enforced. It is the same setup an organization would run in production. A registry is only as useful as what's in it, and that's what authoring is about, describing agents and publishing them for discovery. The better an agent is described, the easier it is to discover, verify, and use it. For this, we will use two examples, an agent skill and an MCP server, described by the Open Agentic Schema framework, both able to generate change logs from Git history. We start by summarizing these records so that we understand what we're working with. A record describes an agent's capabilities in a structured way, the domains it operates in, the skills it has, and the different ways it can be used. This structure is the key because capabilities enable the discovery to match what agents can actually do, not what they're called or identified by. Then, the records are stored locally, signed using OIDC, and announced to the network, making them discoverable not just within our own registry, but by anyone connected with us. Signing is the key part of this workflow. Every record in the directory carries a cryptographic signature tied to the publisher's identity. This is the core idea behind the directory's trust model. Trust isn't assumed or based on reputation. It's provable, attached to the record, and travels with it wherever it goes. The most important feature of directory is the discovery. There are two ways to discover agents: locally within your own registry or across the network where you can find agents published by others. Here, we're going to perform local discovery. We start by describing what we need in plain terms: an agent that can draft release notes from Git commit history. We're not searching by a project name, a package identifier, or a keyword. We're describing a capability, and the directory matches it against the records we published earlier. Discovery and trust aren't separate steps. Every search result already tells you what you're dealing with before you commit to anything. Finding an agent is only half the problem. Installing an agent means running third-party code inside your environment, code with access to your files, your tools, and your workflows. A compromised or malicious agent is a real attack vector. So before using anything, you want to answer two questions. Can I trust where this came from? And can I trust what it actually does? Verification covers both. The signature check proves the record came from a known, verified publisher, while the security check handles the agent itself, its content, behavior, and patterns. Together, they turn security assumptions into verifiable claims, and they work the same way for a record published by you or by anyone else. With trust established, installation becomes a low-risk decision. The agent gets added as a skill into the current project, plugins are reloaded, and the capability is immediately live in the session. Now, we can put the agent to work. We ask it for a summary of last month's changes in our GitHub repo. It fetches the commits, categorizes the changes, and produces a structured, readable summary. Exactly the capability we searched for, now doing the real work. In summary, we found an agent by capability, verified its trust, installed it, and used it, all without any manual coordination or prior knowledge of the agent's existence. Local discovery is useful when the agents you need are in your own registry. But no single registry holds everything. The agents you actually need are often published by other organizations. Distributed discovery lets you search across organizational boundaries, with the same trust guarantees and without any coordination. Once again, we describe what we need in plain terms: an agent that can help with Unix command usage and best practices. This time, though, the search goes beyond our own registry and reaches out to the network, with the results synchronized back to the local directory once found. Before anything is synchronized, we get a discovery matrix: which peers are reachable, how many records each one holds, and which capability is matched. This visibility matters. You can see what's out there and decide what to sync before committing to anything. Once the sync completes, the results appear in the same trust annotated format as local search. Records from another organization arrive with the same structure and the same trust guarantees as our own. Different origin, same transparency. From here, the workflow is identical to what we did locally. Even though the record came from an organization we've never coordinated with, we can establish trust in the same exact way, because trust travels with the record itself. With the verification done, we install the agent and reload plugins. The Unix agent is now live in the session. Similarly, we ask a simple question. What's the best way to check if something exists in a file using Unix commands? The answer is exactly the kind of context-aware, opinionated guidance you'd want from a specialized agent. Not a generic response, but one shaped by its specific focus on this domain. And this is the key takeaway. This agent wasn't in our registry. It was published by another organization on a different node somewhere on the network. We discovered it by capabilities, verified it, and put it to work. And that's the whole life cycle, from setup to getting the work done. No more hunting hoping to find the right agent, no more trusting code because it looks popular, and no more manual coordination between teams or organizations to share what they've built. Discovery, trust, and distribution across frameworks, protocols, and organizations. Thank you. Until next time.